Look at Mount Everest. At over 29,000 feet, it is the roof of the world, a freezing, oxygen-starved environment where life struggles to exist. Geographically, a towering rock peak like this is the farthest physical point you can get from the bottom of an ocean. Yet, the rock at this apex hides a contradiction, a piece of the world that shouldn't be here. Climbers and geologists scaling the death zone near the summit have repeatedly stumbled across something out of place embedded in the ridges. The stone up here is packed with the fossilized remains of ancient marine life. We find sea lilies, fish, and spiraled ammonites. These are organisms that require deep, highly pressurized saltwater environments to survive. How do deep-sea creatures end up resting 8,000 meters above sea level? Either the global oceans once sat 8,000 meters higher than they do today, or the bottom of the sea was forced into the stratosphere. To find the answer, we have to rewind 50 million years and strip the Himalayas off the map. Back then, the Indian subcontinent was an island. Separating it from Asia was a deep body of water called the Tethys Sea. For millions of years, marine creatures lived and died here. Their remains drifted to the seafloor, compressing into a thick layer of limestone sediment. Meanwhile, the plate carrying India was drifting relentlessly north across the globe, straight toward Asia. The Tethys Sea was caught in a planetary-scale vice grip. Eventually, the ocean ran out of room, and the immense Indian landmass slammed directly into the Eurasian plate. Typically, a heavier oceanic plate will slide under a continental plate, but both of these landmasses were of equal density. Neither side could sink. With nowhere else to go, the energy of the crash forced the Earth's crust to crumble, fold, and thrust upward. That limestone sediment from the bottom of the Tethys Sea, the layer holding those marine fossils, was squeezed and pushed to the top of the newly forming peaks. Mount Everest is the exhumed, crushed graveyard of the Tethys Sea. We tend to view this landscape as a finished piece of history, but that collision is still happening. The Indian tectonic plate hasn't stopped. It is still grinding north into the Asian continent today. This chart shows the trend. The Himalayas are still growing, rising approximately 5 millimeters every single year. We see mountains as permanent landmarks because our lives are short. On a geological scale, the Earth's crust is fluid. The Himalayas are a kinetic event unfolding in real time. Those sea fossils near the summit of Everest are the physical evidence of this ongoing tectonic engine. It changes what you see when you look at these peaks. When you look at the Himalayas, you are looking at a crushed, rising ocean floor, suspended in the sky.